to start with, what is reflection? What is reflection API? We have reflection API. We have a package called java.lang.reflect, and in that there are a lot of classes which we generally use. I'll tell about what is reflection API and why that name reflection. Can we create an object of a class without using new? Yes, we can create by using reflection API. There is an API called as reflection API. We can create, of course, by using reflection API without using new operator. I'll show you how it is. First, let me start with a simple example here to demonstrate on it. We just create a new Java project, a normal Java project, reflection. I'll talk a bit on reflection. Okay, here simple, I just create a class, simple class X in com.mysys creating X, and inside this I will write two variables, private string name something, private int I, and I will write one default constructor here. I will write a trace and also one parameterized constructor. Now what I want to do is I want to create an object of class X without using new operator, and also I'll write one more method here, public void do something, just some method which will take some int, some string yes, and here I'll try to print name plus name, the instance variable, plus I is equals to plus I, the instance variable, plus the local variable yes is equals to. So by using reflection API, this is a simple class. By using reflection API, I want to create an object of X using default constructor, using parameterized constructor, and I want to call this method. So in that process, I'll discuss about what is reflection. Okay, I'll just create one more class with main. Also demo, take main method. I'll just say X dot class X dot, see there is a static variable, the name of the variable is class and is of type class. Did I create that variable? No. The compiler, when it is writing the bytecode, it has created that variable. The variable name is class and its type is class. The compiler has written the bytecode for it, right? But why? What is the use? Let us try to understand. What is the meaning of metadata? Data about. So if I want some data about this class X, that is class metadata, right? So if I ask you, can you please tell me the metadata of class X? What do you say? In class X there are two variables called as name and I, and there are two constructors, one default constructor and one parameterized constructor, and one method do something. So if I ask you what is metadata of X, you will say the variables, the constructors available, the methods present, everything, right? Now at runtime, what I want to do is I want the metadata of any given class. You give any class name, I want to read the metadata inside that, right? Actually, if we read Java code .java file, .class file is written by the compiler. So the compiler, what it will do is it will facilitate us. It is possible to access the data, the metadata of class X at runtime by using the variable class. right? By using this class variable here, I will be able to read the metadata that will be this. So to make us to make the metadata available to us at runtime, the compiler has created a static variable called as class, and its type is right. So by using that variable, I will be able to get the metadata of class X. Okay. Now, when is static variable loaded? When is static variable allocated memory? X is having a static variable called as class. When a class is loaded, static variable also will be allocated memory. And if there is any static block in the class, that will be executed, right? So whenever I wrote x.java and I compiled, the compiler has actually introduced the code. In this class X, the compiler has introduced a variable called as class with of type class. And also it has introduced a static block where the class variable is initialized. Right? Somehow the compiler is taking care of initializing this class variable. Right. So now if the class X is loaded, then static variable also will be loaded. So in Java we have a class called as class. In java.lang package we have a class called as class. I just say class dot for name. To this, if I pass any class name as a string, it will load that class, right? So com dot mysys dot x. The static method for name will load this class X. Once class X is loaded, static variable of X also will be loaded. I'll just throw this exception. Okay. The return type of this for name is the class variable of class X. So I'll take it in a variable class C. Now if I say C dot new instance, it will create an object of X. This is a simple way to create an object without using new operator, by using the metadata object class. Right? Let us see whether really class object is X object is created or not. Yes, I saw whatever I wrote inside the default constructor. The default constructor is now invoked. Right? That means the object is created. Right. Now I want to know the metadata. Till now I didn't know about the metadata of class X. I want to know the metadata. I want to invoke a method called as do something. In class X, I have a method called as do something. I want to invoke it. So I should know what all methods are present, right? So what I can do is I can say C dot get method. Get methods. There is a method called as get methods, which will give you array of method objects, right? So there is a class called as method. C dot get methods will give me a method array. Method array methods. What is this class method? You understood about a class called as class. What is the purpose? By using the class object, we can know the metadata of any class. So in this case, I have loaded class X and I got the reference of class of X. So by using that, I will be able to know the metadata of the whole class X. Similarly, if I ask you, tell me about metadata of a method called as do something, what will you say? I want you to tell the metadata of the method called as do something. You will say the method name is do something. It is taking a parameter called as yes of type string, and it is public. Return type is void. This is all metadata of method, right? The method also has a metadata, data about method. To access metadata of any method, we have a class called as method. So we will be getting here method array. So I'll just look through each method. Method yum method colon methods. I just want to print system.out.println method.getName will give me the name. Name of the method. Let me just run. Will I get the method names? Yep, see, these are all the methods present in class X. Are these the methods inherited from object class? So I was able to know about the metadata of the class. I said c.get methods, it gave me method object for each method. I got a method array, method object for each method. By using method object, I can get the name of the method, and you can see method dot get. See, get annotations will return me an annotation array. If I use any annotations on top of the method, I'll be getting all the annotations array. Get exception types. If the method is throwing some exceptions, declare that it throws exceptions. So it will give me all the exception types of that method. And get modifiers will give you the modifiers for that method. Get parameter types will give me a class array of parameter types. Right. Get return type will give you the return type. What is the return type of your method? Right. So by using method object, you will be able to know the metadata of the whole method, any method. Right. So once you understand this, what I want to do right now is, I want to invoke a method whose name is do something. Okay, I'll just comment this code right now. I can get a method object if I know the name. C dot get method. See here, earlier I used get methods. I got method array. I got the method array of all methods. But I am not interested in all the methods. I want the method object for a method whose name is do something. So get method is there. I can pass a method name and parameter types. I'll be getting a method object for that particular method. So the method name is do something. And what are the argument types? String. Second parameter is argument type. String dot class. So this will be returning a method object. Now I want to invoke that method. Okay. Let me tell you some basic thing which you might be already knowing, but just before invoking the method, I'll tell you what is required for invoking the method. In AOP, we will be using this method invocation. So I want to talk about this, how to invoke the method clearly. Okay, just see on the board. In Java class of X, in Java code of X, the method do something is taking a parameter called as yes, right? In a method, can I use this dot name, this dot I to refer to the current object? We use it, right? Can I use any variable without declaration in Java? First we have to declare that variable, then only we can use it. But how am I using this? We say that this is implicitly available. This is an implicit object which represents the current object. Right? Let us try to understand how. You might be knowing it, but just to make it very clear, in Java class my method is like this: do something which is taking string, yes, but when this method is converted to bytecode, it will be like this: do something of this. Do something is present in which class? Class X. First parameter will be the class type and the variable name is this, comma, yes. I'll call you back, Lana. Okay, so this is a bytecode. In Java code, there is only string, as in the bytecode there is one parameter. This will be the first parameter always. On which object are you invoking? Can you invoke a method without an object? Can you invoke this method without an object? No. You have to call an object reference dot do something. Right? These are static methods. Static methods can be invoked without an object, right? Okay. Suppose somewhere I will write like this: x is equals to, say, new x. This is an object reference. Now how do I call x dot do something, and I'll pass some, do something is taking some string ABCD. I'll call like this. This is Java code. In Java code we are writing x dot do something, but when this is converted to bytecode, it will be do something of x comma ABCD. In the bytecode, this code also will be converted to bytecode, right? X dot do something will be converted to do something of x comma ABC. So in the bytecode actual do something, the first parameter is reference of on what object, right? So this is what I want you to understand. So whenever you are calling a method, the method call in Java is like this, but in the bytecode it will be like this, right? When we are using reflection API, we are actually working with metadata, right? So that means metadata of bytecode. Now I want to invoke this method, do something. I got the method object for do something, right? On which object to invoke this method? I need to tell. So to invoke this method, this is how I'll pass method dot, there's a method called as invoke. What is the first parameter for invoking? On what object? X. I have already X object on the top, X. And what is the parameter to be passed? ABC. So this is how to invoke a method. So this will invoke a method called as do something, because this method object is for do something, by on which object? X object, and passing this parameter, right? This is how to invoke a method using reflection API. Why am I calling it as reflection API? In which package is it present? java.lang.reflect.method. Reflection means what, seeing ourselves in a mirror is called as reflection, right? So by giving this class object X, class X is having a variable, static variable called as class. By using that object, it is allowing us to see inside itself only. We are able to see inside X by using the class variable, right? By using this API, what we can do is we can look inside the class. We can get the metadata of a class, get the metadata of a method, get the metadata of a constructor, get the metadata of a field, everything. Right? That's why the API is called as reflection API. By using that API, we will be able to look inside any class, any method, any field, right? So that's what I want to tell. Once yeah, if see, you can directly call x dot. This is direct way of calling it. X dot do something. This is direct way of calling.
No, I mean this method dot invoke. Instead of method dot invoke, I will write method bracket x comma a.
The method is a reference, right? It's reference. This is reference variable, right? You can call methods only. In method object there is a method called ignorant. It's just a reference. Oh, why I got name is null and I is equal to 0? We invoked default constructor, is it? Okay, I'll show you how to invoke the parameterized constructor. But before that, one thing. Here the method is public, is it? We can invoke public method, but I'll make it private. Will I be able to invoke? Let us see. Okay, by using reflection API, I am trying to invoke a private method. No, what is it saying? No such method. Whenever I say get method, this will return me only public methods. The method which are accessible, not only public methods, the method which are accessible will be returned. Right? But I want all declared methods. Whether it is public, private, protected or anything, I want all declared methods. So I can say get declared method. Instead of saying get method, I can say get declared method. So this will give a method object even though the method is not accessible. If it is just declared there, I'll get the reference. So I'll run it now. Let's see. Now the exception is different. Previously it said no such method. But now what is it saying? Class demo cannot access a member of class X with modifiers. Right? But I want to invoke it. By using reflection API, yes, we will be able to invoke the private method. I'll say method dot set accessible to true. I am saying that method is accessible. Now I will run. I should be able to invoke it. Yes. So by using reflection API, actually we are playing out with metadata, the byte code. So we can even invoke a private method also, private constructor also. We can even access a private variable also. Like yesterday, I told you auto wired. I auto wired on top of a private variable, and I said string will be initializing the private variable also, right? So even though the variable is private, by using reflection API, we can access it. We can set a value to it. We can get a value of it. Now that's fine, I was able to invoke the method, but in this case when I said c.new instance, which constructor was invoked? Default constructor. Now I want to invoke a parameterized constructor. This constructor which is taking string comma int, right? So what I can do is class object c.get declared constructor name. Sorry, constructor will not have a name anyway. Constructor name will be same as the class name. Constructor has parameters, so we have to pass class types of the parameters. String.class, first parameters string.class, comma second parameter is int. I'll say int dot so I will be getting a constructor object. There is a class called as constructor, by using which I can get the metadata of a constructor. I got a constructor object for a constructor which is taking string comma int. Now I'll say constructor dot new instance to invoke that constructor. While invoking the constructor, I need to pass the values. First parameter is string. I'll pass something a comma 20. This will give me a object, so I can type cast it too. So here, by using constructor object, I was able to invoke a parameterized constructor. Let's see. Yes, see, the instance variable names you are getting now. So I was able to invoke a parameterized constructor by using reflection. Any doubts till now? Let me know.
Can you invoke private constructor?
Yes, of course. See here I use actually declared constructor. There is a method called as get constructor. This just like get method, this will give only if the constructor is accessible. If I say get declared constructor, I will get a constructor even though it is not accessible. Let's say I will make my this constructor as private. Okay. So here if I try to run, will it invoke? Illegal access again. So what I need to say, constructor dot set accessible to true. Now I will be able to invoke it. So we can invoke anything, private constructor, we can access private variables, private methods, anything we can do. And most of the containers, all the containers, whether it is servlet container or Spring container or EJB container, what are they doing? They are reading from XML. In XML we will configure what is the class name, what are the parameter properties and properties values, everything. Spring is internally using reflection API to read the XML and then create objects dynamically. Right? Any doubts till now? I'll go to AOP. Okay, so let me just introduce you to what is AOP. I will not talk about what is A, what is O, what is P for some time. Let us talk about a scenario, and based on that I'll introduce. Just see this slide for some time. A simple example. Let's assume that I have an interface called an arithmetic calculator, which is having some add method, subtract method, multiply method, divide method. And unit calculator, another interface which will convert kilogram to pound, kilometer to mile, just two interfaces. Right? First we'll talk about a scenario, then we'll come to AOP. Then this is the implementation of arithmetic calculator interface. Normal logic, a business logic IoT. Then this is the logic for unit calculator. This method is converting kilogram to pound, kilometer to mile. Some logic. Don't worry about the logic. Now a new requirement came in our project. We want to add logging in all the methods, because for debugging it will be helpful, right? So for debugging we write logs, and the famous API for writing logs is log4j. Here I wrote log.info. Before the start of every method I am writing something. The method add begins with A and B. The method add ends with the result. So before and after every method I need to write log. This is a new requirement for log. So what I have to do? I have to open the class again. I need to write the code. Suppose if I have 100 classes in my application already developed, and if I am asked to write logs for each and every method, it is too difficult, right? So I need to modify each and every method and write such a log. Okay, that's when somehow if I manage to write 100 methods, okay, I managed. Let's assume I managed. Okay, I have written like this for each and every method, writing a log before and after, before and after. And in my other class also I wrote a log before, after, before. But then a new requirement comes. I want my arithmetic calculator to work only for positive numbers. I want to write some validation logic, right? Maybe for many of our classes, some of the parameters have to be validated. If this parameter is an accepted parameter or not. For my calculator, I want to validate, saying A should be greater than 0, B should be. So in add method, what I did, I wrote validate A, validate B, validate A, validate B. And this is a validate method. It is just checking if A less than 0, throwing an exception. So this is new requirement, right? Validate. So what you observed till now is what is my actual business logic of add method? Just to add A and B and return it. Simple logic. But logging is another requirement which came in the middle. Validation is another requirement which is coming in the middle. Is this logging only for a single class? No, for my whole application I want logging. And validation also, is it for only particular methods? Maybe I want the validation for n number of methods. Each method will be taking parameters. I want to write logic for n number of methods. So now the idea is why to write this type of code like logging and validating in each and every class and each and every method. Why can't we keep it in a separate place and let that code be called before and after every method? That is the idea, right? So in our class, if you see, the code which represents our business logic is called as business concern. Right? Just I am introducing the terminology. In add method, what is the business concern? A plus B, and returning is a business logic. Our business logic, the code which contains our business logic is called as business concern, right? And non-business code, like logging code, validating code, this is non-business code. This non-business code is called as cross-cutting concern. Why the name cross-cutting concern? Business concern, you are satisfied because it contains business logic, you are satisfied. Business concern. Such type of code like logging, which is not a business requirement, is not a business logic, is called as cross-cutting concern. Why? Because such type of code should be executed before my method and after my method, right? So it is actually cutting my code. This is my actual code. It's coming before my code is executed. This code is executed, and after my code is executed, this code is executed. So it is intercepting my actual code. Before my code is actually executed, my logging code is intercepting it, right? So we say such a code as cross-cutting code, right? Because this code can be applied at many places, not only inside a single method. It can be applied over many places, right? So I introduced you to new terminologies too. Business concern, cross-cutting concern. Example of cross-cutting concern. Security. Security is a cross-cutting concern. How? Let me tell you. Let's say I have another requirement saying that this division method should be allowed to be called only by admin. In our organization there will be a lot of roles. I want my division method to be accessed by only a role called as admin. If somebody else tries to call it, I want an exception to be thrown. Right? Like that, in my application there are 100 methods, and I want to say for some methods I want admin to access it. For some methods I want employee to access. I want HR to access. Right? So security, is it a business logic? No. Again, security, it can be applied for n number of methods. Common code, right? The security code is also a common code which can be applied before and after every method. Right? Security is also a cross-cutting code. It's not a business logic. It's a cross-cutting code. It can be executed before a method. Before calling your original method, it can be executed. Right? So now, where to write such cross-cutting code? I said it is not a good idea to write your cross-cutting code inside your original methods, because instead of writing your business logic in your original method, you will end up writing some unnecessary structures. Right? So now the idea is, don't write your cross-cutting code in your business methods. Write in a separate class. Right? That is the idea. Now, how does it work? If you are using Spring, who is creating objects? The container. Container is internally using reflection, creating objects and giving it to you, right? So when you are using Spring, if you want any object, you will ask the container to get a bean, give me a bean, right? So now see here, this is my calculator object in which there are add method, multiply method, division method, everything. This is another object which is containing a method called as log before, log after. This log before method will have a code which has to be logged before calling the method. Log after will be having a code which has to be called after executing every method. So I have written my cross-cutting code in a single class, some centralized class, right? Now when using Spring, I will ask the container to give me an object of calculator. But what the container can do is, instead of giving me the original calculator object, it can give me a proxy of calculator. What is a proxy? Any object which acts as if it is the original object is a proxy, right? So my calculator class is implementing which interface? Arithmetic calculator interface, right? If I write any other class which is implementing same interface, if I write my own class implementing same interface, I'll be having all the methods here also, right? So proxy will have all the methods of the original class, right? So if a proxy can be given to me, the proxy also has add method, subtract method, division method, multiply method. So whenever I ask the container, if the container can give me a proxy of the original object instead of giving the original object, I will be working on a proxy. Now the client will be calling methods on a proxy. What this proxy can do is, before it can call the original method here, it can call your log before method. After your log before method is executed, then the original method is executed. Suppose if I call add method with 2, 3, add method is there in the proxy. If I call add method in the proxy, what it will do? It will call log before. Then after calling log before, the control will come back again to proxy. Then to call the add method, right? After the add method is executed, again the control will come to proxy. Then the proxy will call log after method, right? This is the idea. Yeah, there are two types of proxies: static proxy, dynamic proxy. I can write a class implementing arithmetic calculator interface, and I can make sure that whenever I call add method on my static proxy, I can write a code to call log before, then call the original method, then I can write my own class, right? But in JDK 1.3 version, they have introduced a class called as proxy, by using which we can create a proxy dynamically. See, there are two ways to create objects. Can we create an object without a dot class file? Dot class definition? We cannot create an object without dot class definition, right? Generally, if I am writing a .java file, I will compile it. Dot class file will be there in my class path. But it is possible that a class definition can be created in memory. If a class definition is created in memory, I can use that class definition to create. So that is the technique internally used. I'll show you how to create a dynamic proxy now using that way. Okay. So in JDK 1.3, there is some code already which will allow us to create dynamic proxies, right? So JDKs. No, there are two ways to create proxies, by using JDK, and also there is a third-party library called as CGlib, right, which will introspect the bytecode and do it. Okay, I'll talk about when to use Java JDK, when we can use JDK for creating proxies, and when we have to use CGlib for creating proxies. That is something I will talk about. Till now, is it fine? So I'll just tell you a scenario. What I want to do is I want to write an interface called as calculator, which will have add method, subtract method, division method. I'll write an implementation for it. I want to write a proxy for my calculator, which will internally write the logging code. That's my function. So first I'll start with the interface. So I'll write an interface calculator. Here I'll write some simple methods, public int add, which will take int I comma int j, and one more method I'll take, public subtract int I comma int j. Return type is int. And I will write an implementation of this calculator first. Implements calculator. Here the business logic, it's very simple. I'll just write an I plus j here. And here I'll just return I minus j. And just for understanding, I'll just write system.out.println. Inside sum. Here also I'll write inside. Now I want a proxy which will do the logging, right? Okay. I'll write a new class, proxy demo, and take one. There is a class called as proxy. First I'll create an object of arithmetic calculator first, for which I want to create a proxy. For this object I want to create a proxy. So what I'll do is, first proxy, there's a class called as proxy in java.lang.reflect package. Dot new proxy instance. If you just call this method, you will get a proxy. New proxy instance. For which proxy? For which object? Arithmetic calculator, right? What this new proxy instance will be doing is, it will be returning you an object which is implementing same interfaces as a calculator, right? This proxy.new proxy instance, this method will create a class definition in memory, right? It will create a class definition in memory. It will be like this: calci dollar implements calculator, something like this. This definition, there is no dot class file, it will be created in memory. It will be implementing the calculator interface, right? So this method has to create a class which is implementing same interface as my calculator, right? The second parameter is, I talk about first parameter. Second parameter is class array of all interfaces implemented by my arithmetic calculator. So I will do like this. My arithmetic calculator interfaces new class array. This is an array of class what? Calculator. Calculator dot. So now second parameter tells what interfaces the proxy should implement, what interface types. I can give more than one. It's a class loader. In this case, my arithmetic calculator is implementing only one interface, so I gave one. That is second parameter, right? So what it will do, proxy.new proxy instance method. In memory, it will create a class implementing same interfaces, right? And then it will give you an object. Return type object is an object. It will be giving you a proxy object. It will be creating a proxy object using reflection, right? So before object is created, class has to be loaded, right? Now the thing is, the class should be loaded by the same class loader which has loaded calculator. This is the actual target, right? Some class loader might have loaded arithmetic calculator. The proxy object also should be loaded by the same class loader. So we should give the class loader object which has loaded this arithmetic. So how to get it? Simple. Calculator dot get class will give the class object, the static variable class. Dot get class loader will give me the class loader instance which has loaded my arithmetic calculator, right? So to this new proxy instance, I have given the reference of the class loader which has loaded my arithmetic calculator, and also I have told what all interfaces to be implemented by the proxy, right? Then the third parameter is an object of invocation handler. What is the third parameter? See, it's of type invocation handler, right? So what is this invocation handler? See here, I'll just write that new class implementing that interface so that I can pass it as a third parameter. I'll write logging invocation handler implements invocation handler. So I need to implement interface invocation handler, and there's only one method called as invoke. The first parameter is nothing but the proxy object. I'll tell you how the call comes here. Second parameter is a method object. Third one is the parameters. So here just see my logic. I'm writing private object target, and I'll write a constructor which is taking this target, and just see the logic. I'll explain you the logic. And here what I'm doing is method dot invoke. The first parameter I'll pass target comma parameters, and before that I'll write system.out.println before and system.out.println after. I'll modify this code later again. Method.invoke will invoke the method and return value. So object return value is equals to, and I will return this. Okay, now I'll explain you the logic. In proxy demo, I'll pass the third parameter is an object of invocation handler. I'll say new logging invocation handler, and target I'll pass as calculator. Now just understand, just clearly see here what it will be doing. It will be returning an object of a class which is implementing calculator. I'll typecast it. Then I'll call calc dot add 1 comma 4. Let us see. Before, inside, add, after. Now I'll explain you the logic. What is this proxy dot new proxy instance doing? As I said, it will be creating a class definition in memory. That class will be implementing all the interfaces which I pass as second parameter. Right? So in this case, it will be implementing calculator. There will be add method. So there will be public int add, which will be taking int I comma int j. Who is giving this implementation? It is done dynamically, right? What this will be doing is, it will be calling the third parameter is what invocation handler. This object will be having a reference of invocation handler, the third parameter. This class will be having a reference of the invocation handler. What this will be doing is, it will be just calling invocation handler dot invoke. That's all. And the parameter. Similarly, in the subtract method also, no code at all. In subtract method also, it will just call invocation handler dot invoke. But see the parameters for invocation handler dot invoke. First one is proxy. So can I pass this? This is an object of proxy. The first parameter this, comma. Second parameter is what? Method object. Method object for what? Add method. So actually this is add method, right? Can I get method object for add method? Yes, by using reflection, right? So here in before this invocation handler dot invoke, here there will be some reflection code which will create method object for add method, right? And that will be passed. Third parameter is object array of all the parameters. For my add method I gave 1 comma 4. So the third parameter is object array of all the parameters. So here I and j are passed. It will create an object array and pass this I and j, right? So what is the implementation of subtract method? Same, but the second parameter is method object for subtract and arguments for that thing. That's all. So this is the proxy implementation created dynamically, right? Who is creating the dynamic proxy? This method, proxy dot new proxy, right? Now what is the second parameter for invoke? Method object. Suppose if I am invoking add method, this method object represents add method of my arithmetic calculator, right? So method dot invoke will actually invoke the add method on my arithmetic calculator, right? Method dot invoke, I am passing on which object? Target. How am I passing the target? In the constructor I am passing the target. What is the target of this proxy? So this will invoke the method on the target, right? And give the return value. Before invoking the original method, I can write some logic here. After invoking the original method, I can write some logic here, right? So this is the best place for writing your cross-cutting code. Here I can write logging statements. Before invoking the original method, here I can write logging statements, and here I can write logging statements. And if you want to write security code, you can write it inside this. Before calling the original method, you can write security code, right? So as I said, what you can do is you can write your security code, logging code in a separate class and call the method. Before this method, before the original method is invoked, you can call object, separate object dot log before. Here you can call logging object dot log after, separate object, right? So this is how to create a dynamic proxy. Any doubts? Yes. Yes. I'll show you. I'll create one more proxy, one more handler. Invocation handler is the place where I am writing cross-cutting code right now, right? I will write one more class, say validation handler. Implements invocation handler. Okay. Here also the first parameter is a proxy object, second parameter is a method object, third parameter is a params. Here also I'll create a variable called as target, which represents the target for this handler. Then give a constructor, and here I will write method dot invoke on target comma params. I'll be getting a return value. Object return value is equals to, here I'll write invalidation handler before. Invalidation handler after, and I will return the. So here I am having two invocation handlers, right? Now see what I am doing in my props. Here this object is pointing to a proxy which will be invoking logging handler. This proxy will be invoking logging invocation handler, right? Can I create a proxy to this proxy? This is also an object. I can create proxy to proxy. See how I create. Again, I'll say calculator. That proxy also will be implementing same interface. Is equals to proxy dot new proxy instance, but now cals dot get class loader. Second parameter is what? Again, this proxy also should implement same interfaces. What I can do is I can do like this: cal dot get class dot get interfaces. This will give all the interface array which this cal is implementing, right? Here also I could have used same, right? Then third parameter is new validation handler for the target is now cal. Right? So now if I run it, see here what will happen. We have created a proxy to proxy. Okay, this is calc.add. Yes, correct. Now I should see. First, when I invoked a method validation handler, right? Okay, first invalidation handler before. Then it has invoked the original method. Original method on the target proxy. Then, so what I have done is proxy to proxy. We can create proxy to proxy to proxy to proxy to proxy, and number of proxies. Right? So in AOP, it's all about creating proxies automatically. Right? Till now I didn't talk about AOP. Nothing. I didn't talk anything about A or O or P. Till now we discussed generally. Before going to AOP, these are the concepts. You understand?